Welcome to all of you. As in the previous class, we have discussed about the linear programming problems concept. Today I am going to tell you more details about the linear programming problems with the help of some examples. As I told you earlier that in this concept we are going to find the optimal solution of the objective function. So as we are seeing in the first question, we have to maximize the objective function which is given as 3x plus 2y. Relating to the subject constraint, some linear inequalities are given: x plus 2y less than equal to 10, 3x plus y less than equal to 15, and x y greater than or equal to 0. Now as we have the given constants x plus 2y less than equal to 10, 3x plus y less than equal to 15, and x y greater than equal to 0. Finding solution of the constant as per the linear inequality system, and we get the points which we are going to draw on the graph. After drawing the graph, as you are seeing the graph, you all can draw the graph using the concept of system of linear inequalities, and as it is given x plus 2y is less than equal to 10, then it shifts towards the origin. 3x plus y also less than equal to 15, it also shifts towards the origin. So the bounded region between the lines we get is the feasible region that you all are seeing in the graph. Plot all the corner points of this feasible region. Just as I have plotted, the points are 0, 5, 4, 3, 5, 0. These are the points, corner points of the feasible region. Now using the corner point method, taking these points and putting these points in the objective function, we get the maximum value at the point 4, 3, and the maximum value is 18. So in this way we can find the optimal solution. The optimal solution is 4, 3, and the maximum value of the objective function is 18. Now we are going to see one more question. An aeroplane can carry a maximum of 200 passengers. A profit of rupees 1000 is made on each executive class ticket and rupees 600 is made on each economy class ticket. The airlines reserves at least 20 seats for executive class. However, at least 4 times as many passengers prefer to travel by economy class than by the executive class. So we have to determine how many tickets of each type must be sold in order to maximize the profit. So the objective function here is to maximize the profit, and we have to calculate number of tickets of each type. So let number of passengers of executive class equal to x and number of passengers of economy class equal to y. To maximize the profit, the objective function is z, which is equal to 1000x, as the profit on the executive class is rupees 1000, and plus 600 as the profit is rupees 600. Now subject constants given are x plus y less than equal to 200, as the question is saying maximum number of 200 passengers can be carried. Also it is given that the airline reserve at least 20 seats for executive class, so x is greater than or equal to 20. Also 4 times, at least 4 times as many passengers prefer to travel by economy class, so y minus 4x greater than or equal to 0. Also x and y greater than equal to 0. Now we have 4 constraints here. Solving these constraints and putting them on the graph, we get this type of curve, as you are seeing the curve. Again the bounded region you got, and plot the corner points. You should draw the graph on the graph sheet to make it understand more clear what are the corner points. So in this graph, the corner points that we are getting are A, B and C. A is 20, 80, B is 40, 160, and C is 20, 180. So after drawing the graph, you again take the corner points and the objective function and put the value of corner point in the objective function to get the maximum profit which obtained on 40 and 160. The maximum profit is 1,36,000. That is, number of tickets of executive class is 40, number of tickets of economy class is 160, and the profit is rupees 1,36,000. We are going to see one more question. There is a toy company that manufactured 2 dolls A and B. Market test and available resource have indicated that combined production level should not exceed $1,200 per week. That is, the total production of both the dolls must not exceed 1200, and demand for dolls of type B is at most half of that for dolls of type A. That is, the most demanding doll is doll A. Further, the production level of dolls of type A can exceed 3 times the production of dolls of other type by at most 600 units. If company makes profit of rupees 12 and rupees 16 per doll on A and B, how many of each should be prepared weekly in order to maximize the profit? Now, as per the question, let the number of dolls of A is X, let the number of dolls of B is Y. Since we have to maximize the profit, the objective function is Z, which is equal to profit as given as 12 and 16, 12x plus 16y. Given subject constants are x plus y less than equal to 1200, as the combined capacity should not exceed more than 1200. Also, the production given, the demand for the dolls of type B is half that of A, that is y less than equal to x by 2. And also it is given that the production level of A can exceed 3 times the production of doll B by at most 600 unit, that is x minus 3y less than equal to 600. If it is given at least, then the sign should be greater and equal, and if it is given at most, the sign should be less than equal, and also the arbitrary constant xy greater than equal to 0. Again, solving the constant using the system of linear equalities and drawing it on the graph, we'll get the graph of this type. You all can draw the graph on the graph sheet to make it understand more clearly. Again, by the corner methods, plot the corner points and put that corner point in the objective function to find the maximum value which you will get at C point, that is 800 comma 400, means number of dolls of A produced is equal to 800 and number of dolls of B produced is equal to 400. Now, as we come to the end of the topic, summary of the topic is, in this context, the first thing that we need to find is to find the objective function, then the related subject constant, that is the equations or inequalities, solving them using the concept of system of linear equation or inequalities, plotting the points on the graph, finding the feasible reason, and then finding the corner points, substituting those corner points in objective function to find the optimal solution. So in this context, the most important thing is that we need to make equation or inequalities, and then to solve it, we have to draw the graph, and then we have to find out the corner points to find our objective function and to find our optimal solution. You try most of the question and you will able to do it. If you find any difficulty, you can message me also, and in the next part of the video I will explain you a problem related to transportation. Thank you.